All right, guys, test 29. Can't believe it. Let's do this thing. First one says find derivative of a if f of x is x over x plus 1. So your favorite limit is going to take care of that for us. I'm going to say limit as h approaches 0 of f of h plus a minus f of a all over h. It's going to work that thing out. It's going to look like this. The limit as h approaches 0. If I'll plug h plus a in there, I'm going to get h plus a, golly, sorry about that, h plus a over h plus a plus 1. And then if I plug a in there, I'm getting a over a plus 1 all over h. And you know, we've done 100 of these, it seems like. Always doing the same. We're going to multiply by the LCD to get rid of the fraction on the top. I might have rearranged the order there just a little bit, but that's okay. All right, so in my numerator, once I multiply that out, I'm going to get, basically, if you'll think about this way, you really just cross multiply on your numerator. Doing a plus 1 times h plus a, and you're doing minus a times. And if you look at that right there, we just basically cross multiplied the numerator. That happens every time. On the denominator, I'm just going to leave it all multiplied. Remember, I don't think we've ever multiplied out the denominator the last couple weeks. Let's work out your numerator here, meaning do all the multiplication. So I'm going to do FOIL, do first, outer, inner, and last, and then distribute the A. It's a bunch of stuff. All right. Now, let's see what we can cancel. Hopefully a bunch of stuff. The AH's are gone. The A squares are gone. The A, yes, everything cancels except the H. And what I forgot to write on the bottom, of course, is all the, I was about to say it's going to be crazy that everything cancels, but I forgot to write that down there. Okay, so also your H on top, H on bottom cancels. So that leaves me with the limit of 1 over a plus 1 times a plus h plus 1. Now it's legal to plug it in 0, so I'm going to plug in the 0 for h. That leaves me with 1 over a plus 1 and a plus 1, so I'm going to put a plus 1 squared. And there it is. Quite a bit of work for number 1. 1 and 2 will be the most work you probably do on the whole test, I would assume. But we shall see as we go through. Number 2, same thing. Find the derivative, except this time at negative 1, so maybe a little quicker. We shall see. So I'm going to do the same limit as h approaches 0 of f of, this time h minus 1 minus f of negative 1 all over h. So same deal. Let's plug everything in. It's going to be a long fraction right here. I'm going to have 2 minus 3 times h minus 1 plus h minus 1 squared. I'm going to plug in negative 1. If I do that, I get a 2, a plus 3, and a plus 1. That's 6. So I'm going to put minus 6 right there. That saves some time and space. So keep on working. Do the math on the top. I'm going to distribute the 3. I'm going to square, multiply, double square. And I still have the minus 6. Now I'm hoping that 6 is ready to go. I'm looking at it. It sure is, because if I do 2 plus 3 plus 1, that is 6, but minus 6 is minus 6. Let's go ahead while we're doing this, and let's cancel out the h's, the h on the bottom with the h's in your numerator. If I do that, I'm going to get negative 3 plus, oops, sorry about that. Let me take another step. I'm trying to rush too fast, I'm sorry. What that leaves me with in my numerator is an h squared and a minus 5h all over h. Now let's cancel the h's, make it a little cleaner. That will give me just h minus 5. And if I plug in 0, which I can now, I get negative 5. So that's the derivative at negative 1. Whew. Okay, number 3. Final limit as x goes to infinity. Okay, we're approaching infinity now. Think about this. We talked about this week. If you have just an x in your denominator and a kind of constant on your numerator, it's always approaching 0. As x goes to infinity, the bottom is getting bigger and bigger and bigger. The top staying at 3, so we're getting closer to 0. Same thing if you approach negative infinity on this one, except it is a tad bit different. So what I'm going to do here is I'm going to say, okay, limit as x approaches negative infinity. And I'm going to divide all the terms by x squared. So I'm going 4x squared over x squared because that's my largest degree. Same thing in my denominator. And then I'm going to take the limit of each term. So I'm gonna go limit of 4 plus the limit as x approaches negative infinity of 1 over x squared over the limit as x approaches negative infinity of 3 plus limit as x approaches negative infinity of 2 over x squared. Now we know those limits. If you have a constant, the limit's just a constant. You have a constant over x squared, that's going to be 0. You have a constant over x squared, it's going to be 0. So your limit is just 4/3 on that one, just 4/3. All right, number 5, one more limit here. Same deal, the biggest exponent I see is an x cubed, so I'm going to take a second, divide all the terms up by x cubed, so I'm going to get 8x cubed over x cubed plus x over x cubed. On the bottom, I'm going to do a little something different because that one has 1x, that one has 2, and that is 3 altogether. I'm going to divide those up with like 2x minus 1 over x and 2x squared plus 1 over x squared, because that does give me x cubed on the bottom. It gives me x times x squared, which is x cubed. Also makes it very easy to simplify these things. So that leads to, let's go each individual term here. Limit as x goes to infinity of 8 plus the limit as x approaches infinity of 1 over x squared. That's nice. In my denominator, I'm going to have the limit. I'm going to go ahead and break this up. Limit as x goes to infinity of 2 minus limit as x goes to infinity of 1 over x. That's that first parentheses there. And then limit as x approaches infinity of 2 plus limit as x goes to infinity of 1 over x squared. Wow. Okay, so let's work out all these limits. If I have a constant, it's just a constant. If I get it down to this situation like that with a 1 over x squared and over x to the any power, that's just 0. Let's work through the denominator here. Denominator is going to be 2 minus 0 times 2 plus 0. So my numerator is 8. My denominator is 2 times 2, which is 4, by the way. So my limit is 2. All right, keep on going here to 6 and 7, talking about different sequences here. I know really 6 and 7 are just like what we just did on 4 and 5. So still doing those limits. I know they're favorites. So I'm going to limit as n goes to infinity. And I'm going to go ahead and break this up. Since the biggest degree is 1, I'm going to do the 5n divided by n. I'm going to do the n divided by n and the 5 divided by n. I'm going to take the limits of all those. So let's go limit as n approaches infinity of 5. That's the numerator. On my denominator, the limit as n goes to infinity of 1 plus the limit as n goes to infinity of 5 over n. Okay, my numerator is a constant, it's just 5. My denominator is going to be 1 plus the second limit is 0. It's just 5. Okay, so it's convergent. This sequence right here, if we were to add up the terms in it, it's going to get closer and closer and closer and closer to 5. Let's do a couple. Like if you plugged in 1, it'd be 5 over 6. If you plug in 2, it'd be 10 over 7. And if you kept on doing that, you're going to get closer and closer to 5. Just trust me, it's going to take us forever. Number 7, same kind of deal. Let's see what happens here. So I'm going to say, let's go ahead and divide everything. I think you know by now. Divide every single term by n cubed. So I'm going to go n over n cubed minus 1 over n cubed over n cubed over n cubed plus 1 over n cubed. So let's take the limit of all those. Should be pretty quick here. Of course, it takes a minute to write them down. Minus limit of n goes to infinity of 1 over n cubed over the limit as n goes to infinity of 1 over, that's just 1, sorry. Just 1 over n cubed over n cubed is 1, minus the limit as n goes to infinity of 1 over n cubed. Okay, let's fill them out now. The numerator, I'm going to get 0 minus 0. That makes it pretty easy. My denominator is going to be 1 minus 0. So I get 0 over 1, which is 0. So it is convergent also. It is converging on 0 because, you know, the bottom has a cubic. And so what happens there is the denominator is getting bigger and bigger and bigger while the top isn't. So it's definitely getting closer to 0. Also, Don't forget your horizontal asymptote rules, because that kind of does tell your answer there. Okay, so we can find number 8 on this page. Number 8. Okay, back to review here. Got a log equation with subtraction. Remember, you can't subtract logs, you really divide. So I'm going to say x plus 15 over x minus 1 equals 2. And now, whenever you have one log, you're going to do the 3 to that power equals that. So I'm going to say x plus 15 over x minus 1 equals 3 squared, which is 9. I'm going to cross multiply now. Like this. Let's move that x over. Let's move the 9 over also. And you get x is 3. Now make sure with the log equation, make sure you check all your answers. That checks out great. Number 9 has a cube, and I think by now y'all pretty much know that when you see something cubed, you're thinking 1, 3, 3, 1 is your pattern for your coefficients. This is a weird one though, because it's got an I in there. So let's just do the same pattern anyway. So I got 1 cubed first. I have 3. The 1 starts coming down, the I starts coming up. I have another 3. The 1 comes down, the I is coming up. And then I'm going to end up with an I cubed. And what I forgot here is that the minus sign alternates the signs. So the second one should have been negative. Okay, now we're good. So I get 1. That's going to be 3i. Now that's an I squared. Remember, I squared is -1, which is going to make that 3 become -3. And then I cubed. Now I cubed is a weird case. I cubed is really I squared times I. I squared is -1 times I would be negative I. So that's really minus negative I, which is plus I. I hope that makes some sense right there. You can go watch that again if you need to. 1 minus 3 is -2. Add your i's, it's also -2i. And that's where you got to stop. All right, number 10. The key word in number 10 is the word evaluate. Evaluate means find the value. So first of all, because there's subtraction, I'm going to divide. 192 divided by 3, everybody knows that's 64. Then it's asking you 4 to what power is 64? The answer is 3. So there's the value, there's the evaluate. A lot of logs on this test. Number 11, use the log to condense. When it says condense, that means 1 log, right? 1 log in your answer. So that 2 on the outside, let's just go ahead and distribute that. That's going to be 2 log base 5x, 4 log base 5y, and 6 log base 5z. Now, those numbers in front of the exponents, it's really x squared, that's y to the 4th, and that's z to the 6th. Now, when we did logs way back, we talked about any log that was positive, when you combine them, always ends up in your numerator. Any log that was negative ends up in your denominator, because it means divide. So my first 2, I'm going to multiply the x squared and the y 4th. The last one, I'm going to divide by the z6, and there you go. That's all you got to do on that one. Number 12, it's just behind x here because x is the exponent. Obviously, we're going to do log both sides, so the exponents go in the front. I'm going to use ln to keep it shorter. X minus 1 ln 9. I'm going to distribute over here, the right-hand side, make it x ln 9 minus 1 ln 9. And because of x's on both sides, you got to combine the x's. So I'm going to put both of the x's on the right-hand side, like this. Now, to get the x by itself, you have to factor it out. So I'm going to factor the x out of the 2 natural logs. Now, you don't have to show the step. I think it's a smart step to do. Because those 2 logs on the left-hand side are subtracted, you can make them 1 log by doing division, just like that. That's a 9, by the way, your denominator. Now, to get the x by itself, since it says x times natural log on the left-hand side, I'm going to divide both sides by the natural log. So I'm going to do natural log 9 over natural log 7/9, and just punch it in my calculator. And when I do that, I'm getting 8.7429. And, on Thursday, you can always just take that and plug it in for your x's and make sure it looks good. Okay, 13. Looks like 13 is the last one. More logs. This is like a big log review test. So this has log addition. Remember, you can't add logs. What you do instead, you multiply them. So I'm going to do FOIL here. If I do x minus 5 times x plus 3, I get x squared minus 2x minus 15. That equals 1. Now, because I have 1 log, I'm going to do 9 to that power equals that. So I got x squared minus 2x minus 15. That equals 9 to the first power, which is 9. I'm going to move the 9 over so we can factor, hopefully. If I move 9 over, it becomes 24. Factor that thing, you get x minus 6, x plus 4 equals 0. So it gives me 2 answers, 6 and -4. But you must check them always and make sure the log stays positive. If I put 6 in there and there, it's perfect. If I put -4, nope, -4 will not work. Answer's only 6. All right, hope that helped. Come see me tomorrow before the test if you need to. Hope you do great. See you, bye.